everyone. So today we are going to solve today's daily lead code problem. Problem number 3740, minimum distance between three equal elements 1. So you are basically given an integer array nums. A tuple I, j and k of three distinct indices is good if nums of I equal to nums of j equal to nums of k. The distance of a good tuple is absolute of I minus j plus absolute of j minus k and absolute of k minus I. Okay. Where is this absolute value of x? So return an integer denoting the minimum possible distance of a good tuple. If no good tuple exists, return -1. Okay. So basically, this is very simple question. We have to find the minimum distances like between three same element. Like here, the only good pair tuple is these three ones, and the distance between them is between this first two is 2. This is 1, so 2 plus 1, and this is 3, so 2 plus 1 plus 3 is 6. And what is the constant here? Constant is 100. So we can basically simply do whatever it is said. We can use three for loops and check it is valid or not, because the constant is very less. And further we will optimize it. First we should do in very brute force way. Let's find the size of the vector nums dot size. Now initially we will keep the answer as infinity. Let's declare infinity here. 180 will be good, I think. Now we will just simply use the loops. Plus for j0 j plus j plus plus not 0, it will go from I plus 1 to n to make all the indices distinct. K equal to j plus 1, k less than n, k plus plus. So we have written three loops here. And now if all the indices are same, basically vi equal to vj and vj equal to v of k, then we will update the answer. Answer equal to minimum of answer comma absolute of ij, jk and ki. I minus j plus absolute of j minus k plus absolute of k minus I. And lastly, we will return answer. So if the answer is infinity, what does that mean? That means it does not find any good tuple. So we will simply return -1. Otherwise, we will return answer. So it should work on the samples. Okay, V is not there. So let's rename this as V. It should work now. Yeah, let's submit this. Yeah, it got easy. So what is the time complexity for this? We are simply using three for loops. So the time complexity is order of n cube. So ECH order of n cube. Now we need to further optimize this. So can we make it to the quadratic time complexity like from cubic? Yeah, we can do. Basically, if you see carefully, like if the good indices I is here, J is here, and K is here. So it is always optimal to choose three consecutive uh, indices. Like there may be some also indices where the element are same, but it is always optimal to choose three consecutive indices. So and for also next week we will choose three consecutive indices. So what will be our idea? Our idea will be for this I, we will traverse, and whenever we will found one such element, we will turn on a flag that yeah, we already found the element, and we'll further move forward. And then whenever we will encounter another element, and we will check that have we already got any other element in between them? If it is yes, we will simply calculate the distance between them, and we will find the answer. Basically, what we have to find the distance between these and these, which is simply the distance, like twice the distance between first and the last element. So if we anyhow able to find the distance between first and the last element, then we will able to find absolute of like whatever is asked for. So for now, what will be our idea? Our idea will be for us, for a particular element, we will move forward, and whenever we encounter a element, we will check just that have we already found another element in between them. If not, we will just turn on the flag that yes, we have already found the element, and we'll proceed. And then for the next time, whenever we will found another element, we will just find the distance between them, and we will twice the distance to calculate the answer. So in this case, what we will do, we don't need three loops. We will just need a flag that already have or not a element in between them, which is initially false. Now, while going, if vi equal to vj means we have found a similar answer. So in that case, there will be two scenario. Like if we already have basically we already found another element before, or have not. If we have not found any such element before, we will just turn on the flag true and we'll move on forward. And if we have already found such element, we will just update the answer. The answer equal to minimum of answer comma j minus I, which is the distance between first and last element. I will break the loop because this would be the optimal. And in the answer, we will just twice the answer to calculate it. So it should work. Mhm. Why it is giving problem? Expected member name or this after declaration specifier. Uh, if answer equal to equal to infinity, otherwise to int answer. Okay, we have not erased the loop. Yeah, now this should work. Yeah, it worked. Let's run on the test cases. Yeah, it got AC. So what is the time complexity for this? This is basically we are using simple two loops. So the time complexity for this is quadratic order of n square. So we have optimized this from order of n cube and basically from cubic time complexity to quadratic. Now we have to think that can we make it further optimal, like can we make it linear to calculate the answer? And yeah, we can make it. So what will be the idea for that? Like the idea will be simple, very simple. Like let's consider there are three indices I, j and k, and we will store two vector. One vector will be the position of element, like position of element x. What it will just store, it will store the position of the element x, whatever it will found like recently, like the previous position of the element x. Like if the array is like 2 3 2, so whenever we will, here the position will be 0, here the position of 2 is 0, and when we encounter these two, the position will update to this 0 1 2. So basically this position of x is the last, like the recent position of x whenever we have encountered it. And another vector will be like the distance. So what is the definition of distance of x? So distance of x is the distance between the last occurrence of x and the previous of it. Like if the element is this and now 4, now 1 2, so distance of these two, what will be these two, what is the distance of these two and the previous of it? So is there, as there is no previous two of it, so we will simply keep it like infinity. So for up to this array, the distance of 2 is infinity, because the we will consider that there is a 2 located infinitely a distance apart. For these 3 also, like the distance of 3 is infinity. And for these 2, what will be the distance? As there is a 2 previously appeared. So this will be 2, because from these 2, the distance uh, of the 2 appeared previously is 2. For these 4 is infinity. For these also infinity, and for these 2 it will be 3. Like the 2 appeared before these 2 is 3. So now what will be the idea? Whenever suppose we have found these 2, we will just query, is there any previous 2? And yes, there is a previous 2. So what we will do? We will just simply calculate this distance, which will be stored in the distance vector, and this distance, which is also stored in the distance vector. So that is the simple idea. And once we will found the this distance, we will just multiply it with 2 to find the answer. So let's jump into the editor, and we need just two vector. One is position, which will store the position of e. We will initialize it -1 to like check if it is appeared before or not. And what is the element range of the element? Yeah, the element is 1 to n, so n plus 1 is good. Now we will need another vector, that is distance, which will be infinite initially. Now for we will just simply go through a loop, and if position of the current element not equal to -1, means there are previous occurrences of this element, then we will calculate something. And if no such previous element exists, that means position of bi equal to -1, we won't do anything. And after this calculation, we will just update the position of bi to I. That's simple. Now here, what we will do, we will first update the distance of the current element. So what will be the distance of current index? Basically, the element situated in current index is basically simply I, which is the current position, minus the previous position, which is position of vi. And what will be the answer? Answer will be minimum of answer comma the answer basically distance of I, which is the distance between current indices and the previous one. And also we have to find the distance between the previous and its previous. So basically distance of uh, what is the index of previous element, that is position of v of I. And this should work fine, I think. Yeah, it passes on the samples. Let's submit this in the test case. Yeah, it got AC. So what is the time complexity here? The time complexity, we are simply using for loop. So the time complexity is linear here, that is order of n. And the space complexity also we are using order of n. So in the previous scenario, there was no space complexity. We don't need any space, but here we need space because we have to optimize this. So we have discussed here three approaches, one is the basic brute in the cubic time complexity, then the quadratic, and we have optimized it into the linear time complexity. So that's all for today. Thank you.